So with Unit 6, we are going to get into inference for proportions. Typically, we tackle proportions and then we get into means. Means will come after winter break. We'll come back and do a little bit of proportions before we get started on that, though. So the first thing that we cover is confidence intervals. And I will kind of give you the basic overview of what a confidence interval is today. And then on Friday, we will actually go in and start calculating them, talking about what would be required for an FRQ response based on a confidence interval and how we should interpret them. We'll get into that a little bit today, but it all kind of comes together for an FRQ response on Friday. So, first thing is some vocabulary. We build a confidence interval around something we call a point estimate, and that's just a value used to estimate the population parameter. And we're going to get that from a sample. So it's either going to be a sample mean, an X bar, or it's going to be a sample proportion. That's going to be the center of our confidence interval. Confidence intervals are built on samples. So a confidence interval is an interval estimate of the true population parameter consisting of a point estimate and a margin of error. So the point of a confidence interval is we know that we cannot collect data from an entire population. We know that it's difficult, we know that it's timely, we know that it's costly. So in order to be able to make estimates about what a true population parameter might be, we take samples. And from those samples, we can build intervals where we say, I know that somewhere in between these two numbers or these two proportions, these two means, is the true population parameter. So the margin of error represents the maximum expected difference between the true population parameter and the sample estimate. So basically, how far out do our intervals go? How far does it go to the left? How far does it go to the right? It's always going to be the same number on either side. Margin of error is one value. I typically note it as ME. That's how it's seen for the most part in most textbooks and on the AP exam. A confidence level is the percentage of all possible samples that are expected to capture the true population parameter. And we'll kind of get into this a little bit more once we go over the definition and how to interpret a confidence level. But basically, if I were to do this sample over and over and over and over again, say for instance 100 times, I could say if I was 90% confident that my interval had the true, or my intervals would capture the true proportion of those 100 samples that I took, about 90 of them should have it somewhere in between the lower bound and the upper bound. So confidence level is different than your confidence interval. So the idea of a confidence interval, it gives an interval of plausible values for a parameter based on sample data. So that's kind of a big thing between our confidence intervals and our significance tests. Confidence intervals are built around sample data. And plausible does not mean the same thing as possible. Plausible just means we wouldn't be surprised if the true population parameter was one of these values in this interval. Possible, yes, anything could happen, really. That's why in statistics we're never certain, we're never absolutely sure, we never say exactly this number, we say we estimate it to be this, because technically anything could happen. Technically the population, all of our math could be correct in terms of statistics and the process, but it could just be something different. So it's plausible, possible. It just means we're not going to be surprised if the number falls in this interval. And a nice little comic we like to show when we talk about confidence intervals is Garfield. It says, taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. Well, yeah, he's pretty confident that somewhere in that interval, that's going to be the temperature. And that is a very wide confidence interval. Their confidence level is really high because their interval is so wide. And Garfield says this guy's never wrong because his interval is huge. They're constructed so that we know how much confidence we should have in the interval. It's a big process. Again, we get into the actual calculation of it on Friday. The most common confidence level you will encounter is 95%. I will say most of the time on the AP exam, on tests and quizzes, you will typically encounter a 95% confidence level, just because it's large enough that we can kind of reasonably assume that it's capturing the true proportion. Once you get smaller than that, once you get a lower confidence level, it's a little tighter, it's a smaller of an interval, and you get a little more suspicious of the values. And then once you get too big, just like with Garfield, it's like, yeah, I'm not going to put any thought into that because it's so huge that of course it's going to capture it. The structure of a confidence interval. So to create an interval of plausible values for a parameter, parameters describe populations, we need two components. We need the point estimate, and for the sake of us and this unit, our point estimate is always going to be a p hat, just because we are in the proportions part of inference. Our point estimate is going to be p hat, to use as the midpoint of the interval and a margin of error to account for sampling variability. So that margin of error is our distance to the left and to the right to our upper and lower bounds. So the structure is point estimate plus or minus margin of error. And the margin of error is calculated by multiplying a critical value. And in our case, again, I'm going to let you know that this is something we call Z star, and it will have something to do with Z scores, and standard error of a statistics, which is the standard deviation of the sample statistic. And if you remember, for us, standard deviation for a sample proportion is square root of P 1 minus P all over N. That's going to be our sample standard deviation. And we're going to take that sample statistic again, p hat. Now, I gave you this second line of the structure because in your formula chart, which I'm going to pull down really quickly, on the AP exam, they do provide you with the structure of a confidence interval. So statistic plus or minus critical value times standard error of statistic. They give you the general form just because this general form can be applied to both proportions and to means. You just have to know what you're plugging in, what your problem is asking. And what's nice for us so early on in the year is we know we're only dealing with proportions. So you should not be using X bar. You should not be using standard deviation is population standard deviation over square root of n. That has nothing to do with anything in this unit. We're only dealing with proportions. So again, another example of what the structure is, we have our point estimate in the middle. We go out to the margin of error in the positive direction and the negative direction. And this interval is going to be represented by how confident we are we're capturing the true population parameter. So how do we interpret a confidence interval? This bolded part on your page is going to be how you interpret it every single time. Anytime you are asked to interpret a confidence interval, this is the structure you should follow. We'll say we can be however percent confident the question is asking. 95% is the most common one. We can be percent confident that the interval from, this will be your lower bound, this will be your upper bound. So the interval from 0.02 to 0.03 captures the true. That is very, very important because we are trying to use a sample statistic to estimate a population parameter, the true population parameter. And it's going to be parameter in context. In our case, again, we are dealing with proportions. And again, it is very, 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 very important you have context. What are you talking about? What is the interval actually describing? That is a key thing in a response on the AP exam. So our first example, 2 weeks before the presidential election, a polling organization asked a random sample of registered voters the following question. If the presidential election were held today, would you vote for Joe Biden or Donald Trump? Based on this poll, the 95% confidence interval for the population proportion who favored Joe Biden is 0.48 to 0.54. Now, right now, we're only dealing with proportions, but again, you will always have to ask yourself, do I have a percentage or do I have a mean? In this case, it's a percentage of people. It's not a numerical quantitative question where people are reporting a time or a grade or a height or a length or anything like that. It's just, who would you vote for? Category A, category B. It's a categorical question. So we're going to interpret the confidence interval based on this model. I said we can be 95% because that's how confident they are. 95% confident that the interval from 0.48 to 0.54 captures the true proportion of all registered voters who would vote for Joe Biden in the presidential election. Now, yes, you could very well turn this into percentages, 48% to 54%. That's totally fine. However, they do accept a proportion, a decimal answer. So typically, that's how I write it. I kind of flip back and forth, actually. So either way works. I have my context. Proportion is what I'm dealing with. Registered voters is my population. And what I'm asking them is, who would they vote for if they would vote for Joe Biden in the presidential election? So this, again, this structure is what we will do for confidence intervals the entire time. Even when we get to means, we are following this structure. So it's something you will be very, very familiar with by the end of the course. But just know this is what we will reference back to. This is a part of the confidence interval process. So once we have interpreted the confidence interval, what is the point estimate that was used to create the interval, and what is the margin of error? So one note that I have here is the point estimate is the midpoint of the interval. If you look back, if you scroll back up, we had that picture where the point estimate was directly in the middle, the margin of error goes up, and the margin of error goes down. And it's the distance from that point estimate to the endpoints of the interval. So what I do, you could calculate either one first. Typically, I like to calculate margin of error first, just because it's a little bit easier to see what that distance is and then apply it in order to get your point estimate. So for margin of error, what I did was I took my upper bound of 0.54, I subtracted my lower bound of 0.48, and I divided that by 2. So I took the length of the interval and halved it, because that should be my margin of error. That should be the distance that takes me to the center of my interval. So upper bound minus lower bound all over 2 takes me to my midpoint distance. So 0.03 is my margin of error. Now, I can use 0.03 to calculate what that point estimate is. Now, again, these values are pretty reasonable. You can kind of look at 0.48 and look at 0.54 and find what the middle number should be. But if you want a mathematical way to calculate it, I just took either the upper bound and subtracted 0.03, or I took the lower bound and I added 0.03. Both problems take me to my point estimate being 0.51. So what this means is when I got my sample, the sample proportion was 0.51. And I built my confidence interval around that sample proportion. So 0.51 is my center. It goes out 0.03 in the positive and the negative direction in order to create my confidence interval. And for our last part, based on this poll, a political reporter claims that the majority of registered voters favor Joe Biden. Use the confidence interval to evaluate this claim. Well, so if we note, any value from 0.48 to 0.54 is plausible. Any percentage in between those two numbers could be the true population proportion. Now, that kind of creates a problem for this reporter, because notice that 0.48 is a plausible value. It could be the true proportion. So because 0.48, 0.49, and 0.50 are plausible values, I can't agree, because in order for the majority of registered voters to favor Joe Biden, the percentage would have to be above 50%. And that would mean I would want my confidence interval to entirely be above 50%, because right now with what I have with 0.48 to 0.54, it's very, very possible that he does it. So because of that, because there are plausible values of p less than or equal to 0.50, the interval does not give convincing evidence that a majority, more than 50% of all registered voters, would vote for Joe Biden in the presidential election. It's always nice because typically this lesson comes before election time, so we're kind of running a little behind schedule, but it's okay. Just make sure if there's a value that you are interested in order for it to be something that is plausible, be something that is actually a true statement, it has to fall within the confidence interval. In this case, too many values fell. If everything was, so say for instance, if my confidence interval was 0.54 to 0.58, then I could say, yes, I agree with the political reporter, because all plausible values for the true proportion are above 50%. And a small note again, if I am moving too fast, or say for instance you miss something in terms of typing, I always post my completed notes at the end of the day. So you will be able to see everything that I have kind of gone over so far. Going to give a little bit of time for people to type or write or whatever they are doing. Okay, so now we are going to get into a little bit more on confidence levels. Now, this is the rarer of the two questions that you get asked. Most of the time, they are asking you to interpret a confidence interval, but sometimes they like to switch things up and ask you to interpret a confidence level. So, again, the structure that we are following is what we will follow the entire time. If we take many random samples of the same size from this population, about whatever your confidence level is, about 95% of them will result in an interval that captures the true parameter in context. Again, I like to use the example of if I were to do 100 samples and I were doing 100 samples of the same size, and I created confidence intervals around all of those 100 point estimates, all around those 100 p hats, I could expect, if I'm 95% confident, that 95 of those confidence intervals are going to capture the true proportion. So that's how it's the most easiest way to understand what a confidence level is you're not necessarily confident in the percentage, in the calculation, in the exact sample statistic. You're confident in the process. You're confident in the idea that if I were to do this over and over and over again, I could expect that 95% of the time I'm capturing the true proportion. Not that you're 95% sure you're correct and that your sample statistic is correct. It's just that you're confident you're capturing it that percentage of the time. So, Ms. Contreras is curious about the proportion of RHS students who use TikTok. She takes an SRS of 200 RHS students. Her AP Stats class constructed a 95% confident interval to estimate the true proportion of RHS students who use TikTok. Their result was the interval from 0.82 to 0.90. So we're going to go ahead and get into interpreting the confidence interval. This is again one of those common things that gets mixed up. It's asking for the interval interpretation here. So I'm going to go in and I'm going to say we can be 95% confident that the interval from 0.82 to 0.90 captures the true proportion of all RHS students who use TikTok. So this is following what we just did on the last page, because it's asking for interval, not level, interval. Now for part B, it does ask us to interpret the confidence level. These are two different questions. You really have to pay attention. So if I were to take many random samples of the same size from the population, about 95% of those samples, of those confidence intervals created around those samples, will result in an interval that captures the true proportion of all RHS students who use TikTok. So that's what it means when I say I'm 95% confident, is that I am getting, if I were to do this, use the same procedure correctly, 95% of the time, I should get an interval that captures the true proportion. That's why I say our confidence intervals are plausible values, not all possible values, because sometimes we do get some weird samples. We get a lot of outliers. Maybe an outlier falls into your sample, kind of throws everything off. Just that's why in stats we're never absolutely certain. So confidence interval, confidence level, and for part C, we have true or false. The interval from 0.82 to 0.90 has a 95% chance of containing the true proportion of students who use TikTok regularly. Well, the language here is really, really important. It's saying a 95% chance of containing the true proportion. That's not what a confidence level represents. Again, it represents what's the percentage of your samples that contain the true proportion, not the chance of your interval specifically containing the true proportion. And I will say, I know it's very, very dependent on the wording of the question. They love these as multiple choice questions. They like to ask you which of the following sentences is correct or which one is incorrect. And you have to kind of know what's a confidence level based on samples. That's the big giveaway, is it's just based on what's the percentage of your samples that contain the true proportion. So I said false. 95% confidence means that 95% of the samples will produce intervals that capture the true proportion of all RHS students who use TikTok, not the chance of containing the true proportion. So it's just capturing 95% of the time. It's not necessarily a probability. It's a proportion. Okie dokie. Last thing we are going to cover in our introduction to confidence intervals is a little bit more about the margin of error. So another question that they frequently like to ask on the multiple choice portion of the exam is, how do I change the margin of error? How does this small change in sample size or confidence level, how does it affect the width, the margin of error of my confidence interval? So typically we prefer a small margin of error because you're getting closer to the true proportion if you have a smaller width of your interval. And the margin of error is going to decrease when the confidence level decreases. So to obtain a smaller margin of error, you must be willing to accept less confidence. So if you look at our example, when I have a 95% confidence interval, it's really wide. And that makes sense because I'm more confident in the fact that my larger interval is going to capture the true proportion. And then I dropped my confidence level down to 80. So I'm a little more unsure about it. And because of that, my interval shrunk. So I always like to use the example of, I am 99% confident that you are going to make between a 0 and a 100 on the test. I'm pretty confident because I know typically that's going to be where the grades fall. You either get between a 0 or you get up to 100. So I'm very, very confident in that range, in that interval of values. And then I say, okay, let's bring it down a little bit. Let me give you a better estimate. So I'm about 75% confident that you'll get between a 70 and a 90 on the test. My interval shrunk and my confidence level shrunk because I'm less confident in a smaller interval than I would be in a larger one. So I kind of like to use that as an example. But basically, if you just remember, as margin of error is decreasing, your confidence level could also decrease. It doesn't necessarily have to be that way, because another thing that decreases your margin of error is your sample size. So when sample size increases, your margin of error decreases. If you remember from us talking about sample size and standard deviation, we're going to get a more precise estimate of the parameter by increasing the sample size. Larger samples generally yield narrower confidence intervals. However, larger samples don't affect capture rate and they cost more time and more money. As sample size increases, your variability is starting to decrease because you have a larger representation of your population. So typically standard deviation starts to decrease as your sample size increases. And if you go back to our formula, back to the formula chart formula, a portion of the margin of error is calculated based on standard deviation. So once standard deviation is going down, this entire margin of error starts to decrease. And the margin of error for most sample estimates depends directly on the square root of the sample size, square root of n. Now, this is something that sometimes shows up in the multiple choice section. They ask, how can I have my sample size, or how can I, or have my margin of error, how can I quarter it? If you have 4 times as many people in your sample, so if you take your sample size of 25 and you multiply it by 4 and you get 100 people instead, then your margin of error is going to half. So that's kind of how I like for you guys to remember it, not necessarily as the square root of the sample size. So if I wanted to quarter my margin of error, meaning only take a fourth of it, I would have to take my sample size and multiply it by 16. If I wanted to third my margin of error, I'd have to take my sample size and multiply it by 9. That's kind of the easiest way to remember it. And this is one of those things that sometimes shows up, sometimes it doesn't, but I like to tell you about it instead. I think thinking about it in terms of examples is easier than thinking about it in terms of square root of the sample size. Margin of error does not account for any sources of bias. It is calculated based on the number you give it. Based on the point estimate you plug into the formula, that's what it calculates as. It doesn't ask the question of, was this sample collected randomly? Was this sample collected correctly? How was the question posed? Who did they ask? Is it representative of the population? None of that goes into the actual calculation of a confidence interval. That's why when we get into our formal answer to a confidence interval question, one of the first things we do is go through those 3 conditions we've checked for sampling distributions to make sure it was collected randomly, make sure it was collected and it represents a normal distribution, make sure that we have a reasonable enough sample size to say that we don't have any bias, that 10% condition. That's why we check those things, because the actual calculation doesn't. For our last example, as part of a project, David surveyed a random sample of 40 students from his school. Both of David's parents are dentists, so many of his survey questions had to do with brushing teeth. One of the questions required students to state aloud whether or not they brush their teeth twice a day. David said he was 90% confident that the interval from 0.79 to 0.96 captures the true proportion of all students at the school who brush their teeth twice a day. Explain what would happen to the length of the confidence interval if the confidence level were increased to 99%. So if I get more confident, I typically am going to have a confidence interval that is going to increase in size because it's going to have a larger margin of error. Again, back to those tests. The more confident I get, the larger my interval is, because I'm going to want to make sure I'm capturing the true value. So as confidence level goes up, so does our length of our confidence interval, which basically means our margin of error is increasing. So I said the confidence interval would be wider because increasing the confidence level is going to increase the margin of error. And then it says, explain what would happen to the length of the 90% confidence interval if the sample size was increased to 100 students. So as my sample size increases, my length of my confidence interval is going to decrease. The margin of error decreases because the variability, the standard deviation of the sample, is going to decrease. So as my sample size goes up, I'm getting more people that are representative of my population, meaning that I'm getting closer to that true proportion from the population. So the confidence interval would be narrower than the original 90% confidence interval because increasing the sample size decreases the margin of error. And for our last question, describe one potential source of bias in David's study that is not accounted for by the margin of error. So you could kind of go into, I always say when we're answering these bias questions, there's really no absolute correct answer. And typically, if this was something on an FRQ portion, they have a variety of answers they're willing to accept. But in this case, there is a very, very obvious one. And it's the fact that there's no anonymity in the question. You're sitting there and you're having to tell David that you brush your teeth twice a day. Most people would kind of shy away if they are a person who doesn't brush their teeth at least twice a day from answering that question truthfully because they expect that David wants to hear, yes, I do brush my teeth twice a day. And it doesn't account for the fact that they would lie. And they may know that David's parents are dentists, so they could be embarrassed by the fact that they may not brush their teeth twice a day. And this is something we call response bias. And we talked about this previously before. It basically centers around the idea that you are responding in a way that you think the survey person wants to hear because you're embarrassed by any other response. So this is a response bias situation. Now, we are done for today. We've finished the notes. There is an assignment in MyLab. I think I have posted a little reminder in Google Classroom for you just so that you know when the due date is and that it's an assignment that is due. One thing I do want to say is you don't have to submit anything to that assignment for credit.